really what I want to cover today and unravel a little bit is the philosophy and methodologies for moving your development processes to the cloud and really what the benefits of doing that are. So our agenda for today is, first I'm going to do a brief introduction of who I am and why I think I deserve to be up here talking to you today. What is the goal of development and testing in the cloud? And this is where we're going to get into really what are the business drivers, why are the reasons we would want to move development and testing to the cloud, and what are some of the trends that we're seeing today. Then we'll go over some of the approaches of moving your development processes to the cloud, a demo, and then I'm going to explain who is CloudShare, the company that I work for. I'm going to try not to kill you with text. I do have one slide that has a lot of text on it, but I'm going to try to get as quickly as possible to a demo. So first off, my name is Chris Riley. I am a technology evangelist at CloudShare, and I'm very fond of putting goofy photos, not because, really because the only types of photos I have of myself are kind of goofy. But really what I do, my job is to represent you, the users of our service. I contribute a lot of content. I author books. I'm currently writing a book for Microsoft Press. And there is my Twitter handle, Hoarding Info, if you'd like to follow or tweet at me, as well as CloudShare's Twitter handle. I'm going to be mentioning some words, definitions, terms today that I just want to make sure we're all on the same page on. Because we hear all these terms, and to some people, especially the one at the very top of the list here, DevOps, it means different things to different people. So DevOps, I'm referring to as a culture and philosophy around development and release of applications. ALM, I'm going to be referring to as application lifecycle management, basically everything up to the release process. And then ARA, which is application release automation, which is that last mile after the release process. And I'm also going to talk about a term called environments. And environments we've used collectively in the IT space to mean infrastructure, configurations, and so forth. But I'm gonna wrap this up into something a little bit more comprehensive as it relates to the cloud. And really, environments are a group of infrastructure plus its configurations and the code deployed on it, kind of treating multiple machine configurations as a single entity or a single unit. So let's start with the goal. Let's start with the big picture. Where do we want to go? Where do we want to be in a year, in 2 years, with moving our development processes to the cloud? And it's actually pretty straightforward. One of the things we want to do is increase the number of releases. We would like to release features, updates to our product, both to internal and public users, on a much more frequent basis. And when we talk about traditional development, we're really talking about release cycles in the months, maybe weeks. But when we start to move up the chain of DevOps, we're really talking about days, even hourly releases of code. We would also like to fully automate our dev and release process. So reducing the burden on the organization to push code out to their users, and also making it easy for developers to take what they've written and more quickly see those features in production. We may also want to, quote-unquote, test in production. One of the 10 trends, and this, the reason I put it in quotes is because it's a very uncomfortable statement for those of us who have been around the development processes a long time and realize This is exactly what we've tried to avoid when we talk about QA and so forth, is avoid testing in production. But one of the interesting trends, and you actually see Microsoft doing this with TFS services, is that you're actually releasing features in the product that you don't yet make available to users on very frequently. And what you do is you may have a mechanism that allows you to test those features in production without exposing it to the user and without exposing any sort of risk or stability issues to the user. So that's really what I'm talking here. Now, in conjunction with that, if you are releasing features sooner, you need to be able to fail fast, mean identify issues in a release faster, and revert faster. Now, this is the key, and I'm going to reference back to this in a second. This is the key to being successful in this world. Now, all of this that I've listed here basically defines the concept of continuous integration. And continuous integration today is very bleeding edge. It's not adopted by a lot of organizations, not because they don't understand it, but for the reasons that I'm about to mention. So this is the goal. This is where we want to get. We're not going to get there in one fell swoop. It's going to take some steps, and especially for organizations that have established development teams, it may be even a little bit more effort. And really what it requires is, number one, a culture change. Organizations today may not yet be prepared for more releases, more features, and keeping on top of that. And that really has to do with the processes the development team has established to their product releases. Second, it may, and most of the times, requires changes in the team. What you see a lot of larger organizations facing today is that they have a very strong back-end client-server application development team, and they would like to add mobile front-end or a web front-end to this application, this line of business application that already exists. So how do they do that? They're bringing in a world of continuous integration into a world of traditional app dev. And so this is a big challenge for organizations to reconcile that with their team and tie the teams together. It also means that you need more and better integrated tools. If any of you on the webinar have attended any of the DevOps or the DevOps days or any of the trade shows around the ALM and automation and the development processes, you know how many tools are out there. And you know what kind of fanatics there are around specific types of tools. I mean, there's basically a tool for everything. So not only do you need more of these types of tools, they need to be integrated better with your processes. And finally, it needs to be built from the bottom up. And this is where current organizations are going to struggle, because they were not originally built with the premises around continuous integration when they first started, but now they want to adopt it. How do you do that? And it also poses a large risk because it can be very disruptive to the organization. So what I've done in the way we've kind of think about those who have adopted continuous integration is we kind of look at it as a spectrum. Starting at the bottom is the traditional development. And these are organizations, I'm not saying that their products are old, what I'm saying is their methodologies for developing their applications are more traditional. They're doing more of a waterfall approach, not fully adopting Agile. They are doing monthly releases, and they have full, could be week, month-long QA cycles and testing. Next is where we see a huge influx of adoption, and that is in the area of ALM and ARA. These types of organizations are now embracing bi-monthly, bi-weekly product releases. They usually have a dedicated QA team, and they've started to bring in the ops and the engineering side of their development processes to support the activity of more frequent releases, more frequent testing, communication with the developers when bugs are found, and so forth. And then at the very top of the change is the DevOps community. Those organizations, usually ISVs, who are doing continuous delivery and maybe even releasing their products on an hourly basis. If you've been paying attention to some of the transitions that Microsoft is going through, Microsoft in a lot of their product lines are embracing this strategy, and Microsoft as an organization covers this spectrum in different product groups, which is actually pretty interesting. So let's take a look at this at another angle, because I think sometimes what is implied when we talk about the chain or the hierarchy is that one organization is better than another, and it's not really the case. And it's not all about development maturity. If we look at this as a pyramid where there's far fewer organizations that are actually doing continuous integration today, and there's a lot more in the traditional dev, it also relates to, number one, the types of applications that exist, and number two, the complexity of the environment that the applications have to run on. So what we're seeing is that traditional dev is still overwhelmed, even in organizations that are starting with brand new development teams today, still overwhelmed by big data and client-server type applications, where the continuous integration world is predominantly mobile apps and web applications. Now, in most organizations, and likely in your organization, you have some combination of the two. And I'm not making a claim that big data and client-server type applications can't be continuous integration. I'm just saying that that's where the adoption is today. Now, the one that's going to really get me in trouble is the one on the left side, production environment complexity. Obviously, it would be hard for me to go into any of the startups in the Valley who are doing continuous integration and tell them that their environments are just not complex. I think that they would disagree with me very strongly. But when I talk about complexity, really what I'm referring to is the complexity of the infrastructure that is running these types of applications. And for most web applications, the complexity of the infrastructure is less than a big data or a client-server application. And the reasons for this could be the size of the infrastructure is smaller. Obviously, in the world of big data, you're dealing with very large infrastructure environments. Or it could be because we, I'm sorry, I just got thrown up. In the big data space as well, the relationship of virtual machines in the infrastructure is more critical than in a web application where you're dealing with web servers and database servers that can more or less live independently. So that's really what I'm referring to here. So how can an organization that is either a hybrid organization that has the web applications, the mobile applications, and the database-driven client-server type applications, Win32 applications, how can you move up the chain of DevOps into continuous integration without killing your application and team? And as I've experienced, as I've talked to a lot of organizations who are looking at this, this is really the biggest problem. It's not that they don't understand what continuous integration is. It's the fact that they have to integrate two different types of development cycles together. And it's also the fact that they've already established a development team 5 years ago where continuous integration wasn't even an option. So my claim today is that the only way to do this And the first step that any organization should take, no matter what their complexity is infrastructure as a service. Moving to the cloud, moving your infrastructure, your development infrastructure to the cloud is the easiest way to start embracing and moving up the chain of continuous delivery, release automation, ALM, and so forth. Now, to really kind of dissect that, let's take a look at the components of DevTest/ALM. First, you have development environments, where you code. That's the IDE. Now, most organizations are not going to move their development IDEs into the cloud. There are a lot of developers that remote into machines to do their coding, but the vast majority prefer to have the IDE locally. And maybe even some limited testing and deploying locally. For example, with the latest great stuff you can do with Visual Studio, you can very easily deploy a web application on your local machine and see what it looks like and all of that stuff. Where we do see a lot of people using IDEs in the cloud is where DevOps and your ops team says, we would like to try Visual Studio 2013, or we would like to try a component from your favorite component vendor in Visual Studio. What they may do is, instead of risking their development environments by installing beta versions of product, they might go and do this in the cloud and see what happens there. Once they're happy, then move it into production with their development environments. But really what you see moving into the cloud is the build and test. So build, obviously, moving your source code to a cloud environment, compiling it, maybe running some special scripts behind it, and then you have a configured environment with your code, and then testing both manual and automated testing. Manual testing could be user acceptance testing, where you're hitting the web application via browser, or you're physically logging into the machine and you're trying to run applications. Automated testing, there's a lot of great automation tools out there, which are scripts that you can run automatically on the cloud environments to produce test results and give feedback to your QA engineers. And then the final step of the release process is production. And production really has to do with your type of application. If you are running a web application, your production could be a host, could be an ISP, is very much going to be a web server somewhere that you're pushing your code, and it is essentially cloud. Whereas a client-server application, production may be releasing that product to your internal users for testing and so forth. So I apologize, this is my slide with a lot of words, but I'm going to go over it very quickly because the next slide is the demo. So really what you need in an infrastructure as a service provider in order to allow you to do development and testing in the cloud is you need a concept of environments. Back to what I was talking about before, all cloud providers have virtual machines in infrastructure as a service. But what's important is how those virtual machines work and relate to each other, especially in those client-server and big data applications. This will allow you to move to the cloud today without having to wait for the bottom-up continuous integration process. An environment is the VMs, could be one or many. Their networking configuration could be multiple networks, could be subnets, everything configured, and their memory state, exactly where they left off. With those environments, you need to have the ability to snapshot the entire environment all together, including the memory state and the networking. And you need to be able to share and clone those snapshots very rapidly. So if your organization needs to test 50 instances of your application on identical configurations, each test slightly varied, you can do that. And you need speed. which means I don't know if you face this with your internal IT, but when you want a virtual machine, sometimes it takes you days, but it really should take you minutes. You also need an API because as we start to embrace infrastructure as a service in our development operations, we're going to need to do that bottom-up and full integration. And the only way to do that is with an API and the new term that I'm very fond of, which is programmable infrastructure. An API that allows you to create virtual machines, provision them, access them, and share whole environments all via code, REST code. And then you need tools that are integrated with your developers' IDEs, tools that are integrated with your source repository and your build processes and your test processes. So I've defined for you the path, and step number one of organizations moving their development processes to the cloud. Now let's actually take a look at what some of these things actually look like in applications. So first, I'd like to show you my my Visual Studio, because this is my favorite IDE. But of course, there's a lot of IDEs out there that your developers use. The two most common are going to be Visual Studio and Eclipse. And what you see on the screen here is standard Visual Studio, but on the right, I have an Explorer where I'm actually navigating VMs in the cloud. So just like knowledge workers in organizations live inside their email all day long, developers live inside their IDE. Wouldn't it be nice if the developers could actually go in and view virtual machines directly inside of the cloud without having to go to a special web interface or anything of that sort? Not only that, what they can do is they can resume the environments, like I just resumed this environment. They can suspend the environments. They can add new virtual machines, revert environments from previous snapshots in case they're versioning these environments. Each one of these environments has multiple machines in them. And now that I've deployed my code here, I can actually let's go to this machine here and view my application in the browser directly from here. So even though it's hosted somewhere else, I am accessing my application right here inside of Visual Studio. And you can see I have a lot. Each one of these deployed demos is a build that I've done, an automated build that I've done of my code to the cloud. I didn't have to manually create these environments. They were all based off of a snapshot that I said, this is going to be my base environment for all of my deploys. Why don't we take a look at what that looks like? I'm going to switch to another machine where my application actually is. So this is the same application that you just saw me launch, and it's just the standard ASP.NET application that comes with Visual Studio. What I want you to notice is on the right, I have all the builds that I've run. Some of them I just ran this morning, and I have build definitions. Now, what organizations can do, if I go in and say edit a build definition and go to the process tab here, what organizations can start to do is build custom build templates that allow them to automate the deployment processes in the cloud. And things that would take your developers or your IT department days to do can be done within 3 minutes automatically as a part of the build process. So there's some credentials. I can specify things like, oh, looks like one of my environments is about to suspend. I can specify things like the blueprint, so the base snapshot I want all of my builds to go to. In the case of the build I just showed you, that is a web front end, so a server with IIS, and a SQL server. The SQL Server is where my database, where I'm storing all of the username, passwords, all that, and then the web front end is which actually serving up the web application that that I showed you. So that is my blueprint. All of my builds will start with that multi-machine configuration. They are networked together. They have configuration that I do not want to be a variable in my build. So I want it to be identical every time I run a build. So that's my sample environment. I get to say how long I want these environments to live. So if, for example, I have an outsourced development team in India, they do builds while I'm sleeping in the US, I want them to run the build, have the build snapshot, and then delete it. I don't want it running, but then I can come in the morning and create these environments manually if I need to, or I can even automate it. So this is how you say, I want it to run for 5 hours. I want it to snapshot instantly. I want it to run for an entire work week, whatever you need. Obviously, if you do things like user acceptance testing, you're going to have these run for a long time. So I'm just going to select an option. And then snapshot, latest, or default. Default is always taking the original snapshot, and latest is always taking the latest version of the snapshot. And this will start to make sense very soon when I wrap it all together and actually show you the user interface of managing these environments. So now that I've said where I want my code to go, where I want my build to go in the cloud, automatically provisioned, what I also want to say is if I'm going to do anything special, I can go in and select a specific VM, like I can select the SQL Server, or I can select the web front end. And I can say, on this VM I have a script. And what I want you to do is run this script as soon as the build is complete. So it can be a PowerShell script, it can be an executable, it could be things like Selenium for full automated testing. And you want all of this to run before a QA engineer or any of your developers touch the VM. I can add multiple scripts, I can have different scripts run on different machines. It's all entirely up to you. And this is where the customization becomes pretty much infinite. So once you've defined the build process, and just in case I broke anything here, I'm going to cancel out of it, you run a build. And what's happening behind the scenes is that this environment is being created. Then your code is being copied. Then your code is being compiled. Then all of your scripts are being run. Then a snapshot is being taken, all without you doing anything. Stuff that would literally take no less than 5 hours, probably multiple days of your developers or your ops team's time to do. So I'm going to go ahead and I'm just going to close out of this. We'll let that deploy go. We're going to see where that deploy is actually going. I'm going to switch here to my account where my cloud account where I'm deploying these. And you see a lot of things going on in this environment. This is the administrative layer where all of my builds are automatically going. And actually, the build that I just ran is building up in the background as we speak. But here I can see from an IT perspective, I can see how much time my developers have spent on the VMs, the type of environments they can create. I can see what my other team members are doing with the environments. If they currently have any builds, maybe I need to go in and look at one of their builds. If I'm a QA engineer, I can actually go in here immediately and click on Run. And what I'm going to do is I'm going to select the deployment I just did. Yes, here it is, 8/29/2013. And I'm going to create an instance directly off of that deployment. So I can actually see the machines now in their own encapsulated environment, and I have full access to these machines. So I can, once this environment is provisioned, I can RDP into them, I can test new configurations, I can do whatever I want as a QA engineer. Once I'm done, I can also take a snapshot of this environment and send it to the developers. And that's really powerful. You can imagine a scenario where developers are not, what they get is a bug in a ticketing system, but what they're missing is maybe configuration issues. This allows you to snapshot entire environments exactly where they were left, memory, network state, everything right on the bug, and developers can see if it's an issue related to their code or an issue related to the actual infrastructure. Let's say I want to create an environment from scratch. I can do that by going create environment, and I can say test. I want to test something new. I want to test a new API, or I want to test a new component to our BI application that we've never used before. Easily I can go in and pick virtual machines. I'm just going to do a SQL Server and add them to the environment. As I'm adding machines, they're automatically networked together. I can also upload my own virtual machines and use them for provisioning. Or I can copy a virtual machine from another environment, and it could be that environment that I just did a deployment on. Have to give it a name. Now I have my own environment ready to go within 15 minutes to work with and do my testing. Oops, that name is already in use. There we go. So you can see the power immediately of having infrastructure at your fingertips within minutes versus days, and how this can help your organization move their development processes to the cloud, starting with infrastructure as a service. Obviously, there's a lot of other components to this, such as networking, such as user interface, and so forth, but I'll reserve that for those who are interested to see that later on a private demo. Back to my slides here. So obviously everything I've demoed for you today is built on top of CloudShare. And CloudShare is a public cloud built specifically for development and testing. CloudShare was founded in 2007. We have offices in Israel and California, and we have patents around that environment configuring creation technology that is really unique and you will not find in an Azure or an AWS, and saves the organization tons of times. And each day we see thousands of environments and VMs created. What we have as product offerings is a range going from the individual developer to the enterprise. What I showed you today is the Team Labs product. That's for development teams of 5 or more. But we also have a Pro Plus product, which is a self-service, onesie, twosie developer type product. And then we also have specific solutions for sales demos for ISVs and to demo their product, and technical training to give virtual machines to students and labs for training. So with that, what I'd like to do is present some resources for you and start to solicit any sort of questions you may have about what you saw today, the development and testing processes in the cloud, and anything about the CloudShare product. So go ahead and start to type those questions in the question box, and we will start to address those as they come in. So our first question is about integration. And specifically integration with IDEs. What I showed was an integration with TFS. As you can see, we also have integrations with Eclipse, and we, specifically CloudShare, is working on new integrations all the time. However, this is also why we have a REST-based API, which allows organizations, especially those who are building that bottom-up development integration process, to integrate with their own processes. Okay, questions about recording. I think Sonia's addressed that already. The webinar is recorded, so if you want to share with your coworkers, this is going to be made available on YouTube. And so one of the users is asking if we can explain a little bit more about the integration of dev teams and how some organizations are doing that. You know, what we've seen, so what I was talking about earlier is that organizations are struggling with the process of taking a web app dev team and integrating it with the back-end team that is basically serving as a platform the web team. So there's two things that we're seeing going on. One is a siloed approach where the organizations are actually saying, okay, we're going to keep the dev processes, the management, everything mutually exclusive, and essentially what's going to happen is the back-end team is going to write an API that they're going to publish to the web team. But for continuous integration, this eventually you hit a wall and this is going to limit you. So the other approach is to take a more united front with the teams and actually tie the development processes together. It will still mean two separate sets of tools, but a more collaborative approach allows the integration to happen more seamlessly and allows you to move to those hourly release cycles. Now, typically what happens is the back-end team has fewer releases than the front-end team. So there is still an element of keeping those two things separately, but in every scenario they have to use the cloud. That's the only way. And what they do is they actually give the web front-end team the ability to spin up new back-ends on their own independently with the cloud, because that's the only way for them to kind of run with their integration and variations. Okay. There's more questions specifically on the Team Labs product. For those questions, I'm going to encourage you to go ahead and email me, and we will set up a 30-day trial for you on the Team Labs product and get you some specific answers to your integration questions and how you might use the environments. Up on the screen is also a link to a trial of our Pro Plus product, the personal kind of individual developed product. A good article on development and testing in the cloud related to this webinar, a video of our TFS and Eclipse integration, the full long-winded Team Labs webinar demo, a nice podcast that talks about development and testing in the cloud by the folks over at .NET Rocks. And then finally, an interesting article on why it's so important, why continuous integration actually impacts the success of your application, whether it's internal or a publicly released application. So with that, I would like to thank everybody for their time and encourage you to email us anything specific you would like us to address, or any questions that were not answered or topics not covered, and we can consider that for an upcoming webinar or handle that directly with you offline. Thank you very much and have a great day.